digital dynamic learning hub of XLR, the East. One spot convenient just a walk from LIC and Road. Journey of decade, we have proudly trained over 2 lakh students. We've been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our comfortable classrooms. With high-definition projectors and state-of-the-art space, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer. At the same time, your convenience, maintain consistent. Wanna get started? Join us for a demo or career chat over a cup of coffee at our Dairy branch.
Evening all. I hope I'm audible. Hope everyone. Okay, Shashank sir, good evening.
Good evening, ma'am.
Yeah, you can start the session, sir.
Sure. Right. So, right. So warm good evening to everyone. Welcome to the session. So this is day 4 of our 15-day journey. Right. So let me start. Right. So yesterday we were discussing about GANs, VAs, and the most important, VIP, which is the transformer. Right. So let us continue from there. All right. So let me share my screen. Just give me a minute. All right. All right. So let me first start the session. Okay. So let me take over first. Then I'll come to your doubts if you have. Okay. Already you have started with a lot of questions. First, let me start. Okay. So then I'll be taking up your questions. Okay. Um, good evening. Okay. If it is good evening, it's fine. I think only till good evening we have. Please hold your questions. Okay. So let me first start. Yes, yeah, yeah. Good evening, everyone. Good evening, good evening. All right. All right. So let us continue our journey. Let me start. And this is where we have actually left off yesterday. All right. So if you remember that we were discussing about the architecture of a transformer, right? The a few important things, especially I was giving you a overview of how actually a transformer works and on what mechanism the transformer actually works, and what are the basis of a transformer, right? So these were some of the key things which we were discussing actually, right? Uh, so yeah. And I was actually discussing a few things on the architecture, and I also told you that it actually works on the system of self-attention, right? So attention in the sense is to give importance to a certain giving importance to a certain context, right? You can think of like a certain situation or a scenario. Okay, so that you can think of like a context. All right. And we also discussed that basically the transformer is actually used inside, particularly a few models. And a few models also which we have discussed is the basically the BERT and GPT, right? And I also told you that BERT is basically used for classification tasks. And a very classical example of BERT model, right, which we use in our daily life is the Google search, right? So everybody uses the Google search, right? So if you are using Google search, right, then you are using BERT model, BERT, BERT. Okay, so I'll tell what is BERT. We will also discuss that in detail also, don't worry. It's a very important encoder model which is being used by Google, which is using the transformer architecture. Okay, and we have the decoder, which is the GPT, which is generative pre-trained transformer, which we are using also in the form of ChatGPT, right? So after that, we have one more, which is the encoder and decoder. These models are basically used in the translations, for example, like the Google Translate and all those things. So let us go to the next, thing, which is the role of a transformer, right? When we talk about the role of a transformer, we are talking about the text generation. So you guys might be aware of what kind of a text we are generating. So based on the models which have been built, I also told you how the model actually understands the text what you have given. So we have already talked about a few things, right? How the prompts will be understood. That is the first one, which is the text generation. So how the prompts are understood, how it will consider, or how it will use the model to understand the context. All these things we have discussed yesterday, right? So next is the image generation, and one of the image generation which we are using currently is the DALL-E. Okay, so this DALL-E is basically a combination of both diffusion models and the transformers. Okay, so next is the code generation, and I think many of you, particularly computer science students or data science or analytics students would have generated some code, right, for doing some analysis, particularly especially from a tool like ChatGPT, right? It will give you should give a correct prompt with a correct data set, what you want to give exact, you have to specify in detail. Okay, if you give anything in vague, right, the output also will be a bit vague. Okay, I don't know, have you experienced it or not, but to make ChatGPT understand and give the coding which you want, that requires some skills. You just can't pull or extract something just like that from ChatGPT. That is not possible. So those who have worked on this, for generating of codes or something like that, even Google Gemini is also one of the very good models for generation of programming languages, especially in the field, especially Python, right? Next is the jukebox. Okay, so basically it is the music. It's like a collection of music. So next is the multimodal AI, which is basically combining both the clip and the flamingo for text and vision inputs. That means the text as well as the computer vision is used for the visions, or you can say computer vision is basically used for the vision means like images. I can say in simple language, which is images. So these are the models where the transformer has been actually used. Okay, so these are the models, and a few of them we might know. A few people might be knowing the the models which I have given here, right? So the GPT 1, 2, 3, 4, which is actually being generated, and which is actually I would say in a simple way, to tell that we have used those models in a simple way, because GPT-1 and GPT-2 are actually a failure models. 3, 4 is where the success has come. 3, 3.5, and now 4 and 4.0 is where the success has come for the OpenAI. Next, the BERT models. This is only for understanding, so that is why it is an encoder model only, not for generation. Best example I already gave you is the Google search. So based upon your text, whatever you are giving, that the BERT model will understand what you are asking Google to answer you back, right? It will try to understand what you are giving it. Okay, so this uses the transformer which has the encoder technology to generate, right? So here, sorry, to understand particularly, there is no generation here, right? It is just there is no generation. Please understand, generation in the sense generating new things is what generation is. That is what generative AI is. So here Google is not generating anything, but it is understanding what you are asking it and giving you the output that what is available in the web. It is only giving you what is available in the web. If you see carefully, only what is available, the websites which are available, whatever you have searched, it will give you, right? It will not generate anything. All right. So it is very, it will be a bit difficult for a few people to understand. Sir, it is giving an output. No, that means is it not generating? No, generation means generating something which is new, which is a novel content, right? The ChatGPT, whatever it gives you, it actually uses the old content also. It will also add new things. So it is basically a generator or a generative. We are calling it as generative, but something we can say it as something it is generating. Okay. Next is the text to text transformer, which converts every task to a text generation problem, right? So especially something which is related to a text to text transfer. Next is the BERT. So BERT combines encoder decoder for denoising, auto encoding, and generation. Okay. So yesterday I think yesterday only one person was asking about the denoising. right? So as I already told you that noising means removing the disturbances in the data is what basically the noising is. So denoising means basically completely removing. Sorry, noise is disturbances in the data, right? So denoising means basically removing the unnecessary things from the data. Next is the DALI. This is basically generates images from the text prompts using the transformer based architecture, and everyone would have used. Even it's not just about DALI, you can also generate pictures inside ChatGPT also. ChatGPT also has the image generation, correct? No, so it also has the image generation. So in that image generation, it will use the text to convert into an image using the transformer based architecture. So the next thing is why transformers excel at generative tasks. So this is the biggest question which we need to answer. All right. So we need to answer this particular question, why transformers excel. Now, the first important thing is it has a long range dependencies. So the problems came especially with the models like the RNNs. Then also somewhat it has been rectified by LSTMs. Okay, so RNN is nothing but the recurrent neural network. Those who are into deep learning, you might be understanding. Okay, now I cannot cover what is RNN in detail and all. That is not possible. Okay, there are two things. I'll just tell you briefly, just to make you at least connect with the topic if you are not aware of it, because uh, these are like advanced level of deep learning. So obviously you have to have a bit of knowledge. But even though you don't have, okay, fine, no problem. But there are two things when deep learning started. One is the CNN, one is the RNN. CNN is convolutionary neural networks, which is basically used for model building for images. Okay. And there is one more which is called as RNN. RNN is nothing but recurrent neural networks, which is used for text data, right? So to build a model, it is used for a text data. So now after RNNs, there came a very good, let us forget about the CNN part, keep CNN aside, okay? So after RNN, there is one new technology which has, I can say, you can think of it like as an upgraded technology, upgraded model which has come after RNN, right? The upgraded technology is nothing but the LSTMs. So LSTMs are somewhat advanced, somewhat they are more effective, right? A long short-term memory, but LSTMs were good until transformer came along. Until transformer came along. Once the transformer technology architecture has come in, right? RNNs and LSTMs looked as they were not a great models. Okay, because in their time there were an excellent models. Even good is a small word. Trust me, guys. Trust me, because I've used, even before 2017, I've used deep learning before the transformer came. So I know how RNNs and LSTMs were actually good. So they were good, but these as I told you, this uh, transformer after coming, it changed the entire fate of artificial intelligence. So keeping that in mind, I would say RNNs and LSTMs are not great. Okay, they are not bad, but they are not great. They're somewhere sitting in the middle. Okay, so this parallel processing is not possible inside RNN, which was actually possible with the transformer technology. That is why it is able to parallelly process a huge amount of data very, 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 very faster. Because even it has, so if I was actually, talking about, I think even in news, you would have seen about NVIDIA, right? So it became the most, the company which has more value in the market. there were a lot of companies which were competing, but I knew one day that Nvidia will become or come to the top of the table. Why? Because I've been following Nvidia for the past, I would say, maybe some 15 years. Okay, so I would say 12 to 15 years. I would say I think at least 12 years. Okay, I'm not guaranteeing on 15. I'm not sure, but at least 12 years, 12 to 13 years I've been following. So Nvidia is such a wonderful company which works on AI, right? It manufactures a lot of graphic cards, right? Which it manufactures also the hardware for the supercomputers. So you are using ChatGPT, right? So if you are using ChatGPT, you are using Nvidia. This is what many people don't know. ChatGPT is a GPT model, so it uses transformer. All right, correct? So the transformer. Okay, so all right. So when you say that you're using ChatGPT, it is a transformer-based architecture, right? So transformer is a framework. It's an architecture, right? Every framework or architecture needs a hardware to run on, right? So as you studied in school, that software has to be compensated with a hardware, right? Where you will use the software in the sky? No. You have to use a hardware which supports the software. That hardware of, the hardware, that same hardware which has to be used by the transformer architecture is provided in the form of supercomputers, super performing chips, which are manufactured by Nvidia. So yeah, that is why increasing of generative AI will give increasing of or will make increasing demand for Nvidia chips. Okay, so that is why I told, if you are using Google Colab, you are using Nvidia. If you are using Azure Cloud, you are using Nvidia, because these are the partners, these are the companies which have partnered for supercomputing with Nvidia. Because I've been following, that's what I'm telling you, right? You are using Google Drive, you are using Nvidia, because on which the Google Drive works, that supercomputer, that hardware is manufactured, that chips, semiconductors are manufactured by Nvidia. So this is how things are. And now this transformer architecture, lot of research has been made by Nvidia. That is why they have come up with lot and lots of deep learning stuff. This research area, what Nvidia doing is fascinates me a lot, because I'm basically a person who is a lot of interest in machine learning, deep learning, right? And generative AI stuff. Because I'm more interested. Okay, those who are interested will feel interesting, but those who are not that Gen AI or AI, data science and all, you might not feel that much of interesting, because who manufactures, you don't care. So that is out of the box, keeping that, leaving that apart. So this processing of why all these things I just mentioned. Okay, a few people might feel it is relevant, some might feel it is not relevant, but why I had to mention is, when I'm saying transformers excel at generative tasks or generative AI tasks, I'm talking about a billion parameters. This billion parameters, it has to be processed by using the transistors. So this Nvidia chips provide that CUDA cores, that ray tracing cores. It has billions of transistors which will work to make this possible. So it is all interconnected, whether you like it or not, it is all interconnected. So it has that longer dependency. The models can hold it for longer periods of time. So the processing, so best example is to understand long range dependency, especially is when you are using ChatGPT, right? So when you are using ChatGPT, you have actually you have made chatting. Okay, so you are doing prompting or chatting with the ChatGPT. So you are getting the required task, you are doing something, you're chatting with it. So the model will continue that particular a page will be kept in memory and that model will continue. So even after you're using it for 3 or 4 days, in that particular page, if you don't open a new chat, that same old page, if you are using it, it will remember that model, what you have actually chatted, or what you have communicated, right? Chatted is not a correct word, sorry. What you have communicated with NVIDIA, sorry, communicated with the model, sorry. Okay, what you have communicated with the chat GPT, that will be kept in memory. It is not chat GPT who's keeping in memory, it's not OpenAI, it's a transformer who is making this possible. So talking in a higher perspective, right? If you are able to take what I'm actually telling, so you'll get the higher perspective of understanding how these transformers are working in the real time. There is no AI task without a transformer. In the current generation or in the current world. So it is my job, right, to tell you about these concepts, because we are talking about agentic AI agents, and generative AI, right? So this is the interlinking, thing which is connected, which we all should know, being showing interest in the field of AI. So next is the challenges, which is compute intensive. Yeah, this is the main problem. If you take it as a problem, it is a problem. If you don't take it as a problem, it is not a problem. This requires powerful hardware. This is the main reason that NVIDIA had to manufacture heavy, powerful chips which can support this training and inference. Okay, so next is bias and hallucination. So sometimes this much of power, this much of energy, this much of computation sometimes might cause some issues as well, right? So next is interpretability. Outputs can be difficult to interpret or control, because it is all you're leaving everything on the machine, so it is only doing things. Next is the applications of transformer. Chatbots, right? Assistants, creative writings, data to text, image captions, and video descriptions, synthetic data generation. I was speaking about the synthetic data also. I think second day I was speaking about that. So this is the complicated architecture of a transformer. Okay, I didn't show you this at the first instance, but this is the actual this is the actual picture of what is an transformer is. This is how transformer actually works. Okay, so that was the thing. So let me take some questions. This is a very interesting question, Ankit, right? How you get these thoughts, man? If a transformer is not discovered, what would happen? If a transformer would have not discovered, we would have used some other technology. So maybe if it is not discovered, the amount of agentic AI or generative AI, what we are using in the 2025, right? What you are using kind of right now will not be possible. Maybe it would have taken another 5 years to achieve this. That's it only. That's why I said, how come you get these funny questions? Yeah, that's what, no, technology, maybe another 5 years, you might get transformer ka baap. Who knows? At that time, 5 years down the line, I might be training. Wow, there used to be a technology which is transformer, which was good at that time, but now we have something. Some name of new technology. Now this is there. This is very good. Like this. Maybe I would have. I would be teaching. Next 4 or 5 years down the line. But kind of right now, transformer is working pretty well actually. Across the organizations, one company who is making you very highly is NVIDIA. He is like literally playing with the transformer architecture. He's already, took the patent rights to, improvise transformers from Google, and he was, he also discovered the new graphic cards which have come out, right? 50 series NVIDIA graphic cards. They have come with the second generation transformer. From 2017 to 2024, it was the first generation transformer. So in 2025, actually late 2025's, mid or late 2024, you can see the second generation transformer in action. And 2025, it was fully out into the public, and this second generation is what was researched and developed by NVIDIA itself. Google has not done it. It was NVIDIA who has done it. So all the new graphic cards, what he released, right, 50 series graphic cards, come with that architecture, which is, he named it as Blackwell architecture. It was before, some other name. I forgot the name. Okay, sure, that is not important. Now he came up with a new architecture, which is of second generation transformer with the new deep learning technology, deep learning super sampling 4. So he came up with that, and all of them are using the second generation transformers, which is the Blackwell architecture. Okay, so that was the research which happened. To answer your question, maybe the third generation transformer he would have named. We don't know. No, research will happen. Life will go on. Okay. All right. Fine. Next, sir. Happy Guru. Okay, Siddesh. Thank you so much. How does the self-attention mechanism and transformer work? Why is it important for generative task? If you're asking this question, one thing, sorry, man, you don't hear what I'm teaching properly. Self-attention mechanism is based on context-based understanding. It is based on context-based. All the AI chips are made by NVIDIA. Most of them, I would say 90%, 90 to 95%. Because even you have one more company, AMD also. He's also making AI chips. But as a computer, you are consuming AMD chips also. But to talk on the bigger picture, all the big companies, for example, like Google, Microsoft, RNN is recurrent neural network. CNN is convolutionary neural network. RNN has become outdated because of the transformer. Now I can say literally it is outdated. Really it is outdated. Just before, some 7-8 years, before the transformer came, RNN used to be a big deal. RNN used to be a very big deal. Once the I can say the transformer was out into the public, it made bonkers. Okay. So RNN is basically used for text data. It is used for text data. So it is used to you want me to tell example. Simple example for you to understand, I will tell you. Let us not talk about transformer, because your Google search now is using a transformer. Okay. Because it is using BERT. BERT technology is being used. BERT is a transformer only. Okay. So before 2017, if you are using Google search, it used to use RNN. How? You will search in Google, correct? You search in Google, and if you type some 2 words or 1 word or 3 words, it will predict the next word, correct? That only is an RNN only. It is an RNN. So how it will predict this? It is probability. It is sheer probability. In a simple word, if I have to tell, it is probability. How does it know that what we want to type? Correct? No, think logically. It is for that particular framing of sentence, which will suit. It will calculate the probability. Sir, it will calculate the probability while we are typing. Yes, it will do. It will calculate the probability, and words which have higher probability will be pushed at the top. Something which is having 0.5 probability will come at the something which is having 0.3 probability will come in the second place. So it will calculate in the cluster of words that only we called as a word cloud. Word cloud in NLP. So it will calculate that cluster of words, and it will calculate and it will push on the probability. In that, see, there will be many a times I will tell you, it will suggest, for example, it is suggesting some 6 or 7 words, let us say. There would be many times that you don't need that 6 or 7 words. You are about to type something else. Did that happen to you? That means is Google is wrong? No, it's not. It has done its job, but you want something else. Here nobody is wrong, here nobody is right. So yeah, even in Gmail you are using the autocomplete feature. Everything from RNNs it went to LSTMs. I would say in a simple way that RNNs were good, LSTMs were even better. Transformer is just a rock star. Okay, so it's like that, because I, as a person who has used RNNs, built models in RNNs, I was able to see the difference, because I done it in RNN, I have done LSTMs, I've used in transformers also, I've done in GANs, VAEs, so I've done everything. So I know how things have evolved, right? So those who are directly using transformer, why people are behind this RNN these days today, I don't know. Many people are asking this RNN. It is recurrent neural network which is used for prediction of a certain word or a sentence, or a basically prediction what your Google search is doing. That's it only. It is LSTM, not LMTS. It is LSTM. That means long short term memory. Okay. I'll also speak about the language models. Just be patient. Don't worry. If you are patient, I'll try to cover as much as possible. Okay, because my job is to train, right? So I'll cover whatever amount of data, amount of information is possible. Okay, so just be patient. Let's continue, sir. Yes, that is what only Hamid. Okay, people are asking different in BERT. Okay, sorry. Is BERT the only transformer used in Google search, or does use other transformer models? Currently, Google is using only BERT. Currently using is on. See, one thing I'll tell you, Sidesh. Transformer is owned by Google. Okay, he was the one who created a transformer architecture, first of all. So if something you created, will you use your own, or you will use somebody else's architecture? You tell me. Correct? No, and these architectures to use to build models, to train upon them, it takes some crores and crores and crores and crores of rupees for research team to maintain. That is why only that is what this AI team is well maintained by Sundar Pichai. I told it in the first day itself, if you remember. Yes, this AI team is maintained by Sundar Pichai. This is called as a Google's brain team. They are the one who developed this transformer, all right, and they are the one who developed this BERT technology. Okay, BERT is what actually Google is currently using only BERT. As far as I remember, maybe modified, but recently when I searched, they are using BERT only. Because it is only a classification model, it is only an encoder. It doesn't do any decoding. Only encoding it will do. It's a classification model. So it takes a lot of mental stress. It takes a lot of energy. It takes a lot of power of knowledge for the a research team to do this. It's not just like that cannot be done. So it is difficult over a period of time for Google to move from BERT to some other technology. It is not like this. Tomorrow, no. Sundar Pichai will feel no. I'm done with BERT. We will build one more technology immediately. Build something. No, it's not like that. That is not possible. Okay. Yeah. Yes, Rupesh. Yes. So that is not possible in real time because uh, it is extremely difficult to develop these technologies. So going to the next one, which let us talk about the impact of transformer, how much it is creating inside the generative AI. Okay, so how much of impact it is creating, let us see. Okay, so see, one person was asking that only. I think that his answer, sorry, for him, the answer is in the first line. So before transformers, generative models, that's what I told you. You know, if some transformer would not be there, we would have been still using RNNs and LSTMs. I told you, that was your answer is in the first line. So before transformers, generative models relied heavily on RNNs and LSTMs. Okay, so forget about CNN. As I told you, CNN is for images. Okay, so let us talk about this. Okay, so transformers replaced recurrence with attention, enabling models to capture global context, long-term dependencies far more effectively, right? So models can generate coherent paragraphs, complex images, meaningful code, and even music. So introduced scalable parallelizing architectures, enabling breakthrough models size like 3 and 4, Gemini, everything is a transformer. It is like, everything is God, like that we will say, So in the computer world, now everything is a transformer. Okay, especially in the field of AI. Everything is built upon the transformer architecture. So yeah, that's what is happening. So next is scalability, massive language models. So transformer-based models like the GPT-3, GPT-4 are the largest neural networks ever built. I told you, this transformer is a deep learning. It uses the concept of deep learning. Entire deep learning it will use. Okay, so deep learning is a collection, a powerhouse of neural networks, right? Neural networks are made. Neural networks are nothing but which are made up of artificial neural networks or artificial neurons. Neurons, exactly how our brain functions, the same way the neurons are actually built inside deep learning. Okay, so the same way how our neuron functions, the same way they are built. Okay, that only is getting processed. Okay. Next is impact made it possible to train one model for many tasks using the few shot or zero shot prompting. So this few shot, zero shot, I'll tell you in detail. Okay, so in prompt engineering it will come. So next is multi-domain generative capabilities. So as these are the transformers are the heart of text generation in GPT, BART. BART is different, BERT is different, don't get confused. Okay. So BERT, BERT is not a text generator, BART is BART, because BERT is a encoder only. It's an encoder. It will not generate anything. Okay. It's a classifier. Next is image generation, which is the DALI, stable diffusion, right? And then the audio music generation, which is the jukebox music LM, video generation like the OpenAI Sora, and make a video like a Meta. So code generation, Codex, Alpha Code, right? So I think many of the tools you will be knowing, because many of you would be trying to use many AI tools as possible, right? So I can see a lot of people this is the I can say that you would have already tried a few models as well, correct? So next is the democratization of creativity and automation. So tools like the ChatGPT, GitHub Copilot, Notion AI, Midjourney, Canva AI rely on transformer models. Okay, only a few I mentioned, but if you search for even the Perplexity AI, right, they use the transformer. So I told you, like what doesn't use. Okay, so non-technical users can now create high quality content with simple prompts. Okay. So yeah, impact is lowered the barrier to entry for creativity, productivity, and automation, right? That is absolutely true. That is what I love in the AI generation. Next is industry disruption, especially for personalized tutoring, right? Healthcare, report generation, medical question answering, AI copywriting, image creators, so AI pair programmers, legal and financing like document summarization and contract generation, right? This impact is enabled faster, cheaper, and more often innovative processes across the sectors, right? So every sector is being revolutionized, so that you are aware of, right? So you are seeing the evolution of AI into different sectors as well. So next is it's a catalyst for agentic AI. I told you, we will come right away into agentic AI. I will link this AI, generative AI to agentic AI. That is why I'm going on a journey. Suddenly we'll link it. So this is one link. I will tell you also some other links also. So the transformers powers autonomous agents. Okay, example auto GPT LangChain agents. So that plan and act. Sorry, plan, reason, and act. So all these agents, which we are calling it as AI agents or AI agents only actually, right? Like the auto GPT and all. So they actually use the transformer architecture. I think now you are a bit clear on what is happening in the current industry and the current world. So serve as the brain of agents that use tools, memory, and feedback to complete the goals. So impact is moving towards goal-directed AI systems. That is what is your agentic AI. Yes, that go beyond a single prompt response interactions. Next is in the research and innovation explosion. So massive academic outpost post 2017, because the great only the AI people know the greatness of 2017 year. which is the which is the invention of transformers. 2017 is the year, was the breakthrough for the technology of transformers. Okay. Next is accelerated progress with multimodal AI, few shot prompting and the instruction tuning. Okay. So all the new generation AI models, everything are built on this transformer. Next, let us see what is a language representation model. Okay, so this is very important to understand the concept of AI agents, because all the AI agents or the agentic AI models rely on the language models. Okay, because this is the one which is basically used for constructing a model for all the natural language processing things, right? So okay, so let us try and understand that first. So what is this language representation? Oh my God. अरे यार नहीं I will tell you how to build an own engine. Don't worry. Sir, what is encoder? Is there any decoder model they are using? No, they're not using, because Google search is not a decoder, it's only an encoder. So what is CNN? CNN, I told you already, convolutionary neural network. LSTMs, don't put S again, it is LSTM, long short term memory. Conversion neural network. No, it's not conversion neural network. It is convolutionary. Convolutionary. You can just Google search it, man. Don't put wrong spellings. Okay. Three people are liking it also. Okay, please don't do that. It is convolutionary neural network. It's not conversation neural network. Please. Okay. Long short-term memory, that is for LSTM. What is narrow AI and what are the typical applications? I will talk about that later. Okay. So we have so many issues, so many messages, so many questions. LSTM stands for long short-term memory. Is it a type of recurrent neural network? LSTM is a type of RNN only. That is what I was banging my head. No, I was telling you that only. Used in deep learning, especially for sequence prediction problems, such as speech recognition, language modeling, text generation, video analysis. Yes, man, absolutely right. Is it a question or it's an answer, Amit? It's a question. You're asking me a question or is it an answer? Wherever text data is there, a sequence of data is there everywhere RNN is used. Okay, so I will not tell one application, because wherever you see a sequence of data, okay, so language modeling will come, your example of time series will come, everything will come, because everything is a sequential model. So text is also a sequential model. So yeah, everything comes under RNN. Yeah. What is notion? I'll come there. Chat GPT. Why, Hamid, you are crying for Chat GPT? Yeah, it is helping you only now. Sir, what is Charge PT? Charge PT. This Charge PT. I don't know what is it. Charge PT. I don't know. Sir, about GPT-1, GPT-2. GPT-1 and GPT-2 are failure, man. That is why only it has not been launched into the public. So before something great happens, you will have a lot of failures, no? Like that, OpenAI faced failures in the form of GPT-1 and GPT-2. From GPT-3, it was a success in 2020. Then after that, they launched the GPT-3 into the public in the year 2022 in the form of ChatGPT. Next, it's an app. Okay. Charge bit not charge. Okay. What is ChatGPT? Yeah. Oh my God. It's an AI tool which is used for generative tasks. Replying to fellow colleagues. Sir. Okay. Charge. Oh, okay. Maybe in flow you would have felt for that you're discussing. Okay. Chat GPT. Okay. Thank you, sir. Let's continue. Okay, even I was also shocked with the messages. What is the reason for 1 and 2 failed? Just like that, it failed. They didn't tell me. Jiva. So OpenAI didn't tell me. You should ask Elon Musk that why it failed. Because he's one of the co-founders of he's already busy with his own party. Fighting with Trump, right? So this was long happened before. So because he was one of the co-founders. Elon Musk was the one of the co-founders for ChatGPT. I should not say ChatGPT. I should say OpenAI. Yeah, ChatGPT is an application. OpenAI is the company. I will try to ask. Yeah. Because I also checked actually, they were telling some reasons, this thing, that thing. Uh, uh, on the whole, it didn't went well. It didn't go well actually. Okay. Okay. So let me continue. All right. Let us talk about the large language models. Or I can say language models first. Then we will talk about large language models. And this transformer uses this. It's basically a byproduct of large language model. So yeah, that we will link. Everything will again talk on that. Next is the language representation model, which is the type of a machine learning model which is basically used for text. Okay, so that is why whenever you see the word natural language processing or natural language, it is basically for the text data, right? So what does a language representation model do, right? It basically converts it basically converts into a structured representation. All right. So analyzing the meaning and structure of the text, performing tasks like classification, right, translation. So one such classification task is what this BERT is actually doing, BERT, right? Next is there are three things. Okay. Then we'll go to the models. Okay. First, I'll talk about the functions. So the first one is the okay. So this one was actually a bit of old technology. Okay. This was more focused on on dense words, which are static words. Okay, not on dynamic words. Okay, so they are actually dependent, or they are actually relying on static words, especially embedding models. Models like the word to vector, like that we have. We used to have different kinds of models in embedding. Okay, after that came this context-based understanding. That is in where the transformers actually took over. So understanding the context, for example, the word bank, right? So bank is of different meanings. For example, bank can be considered as a financial institute. There is also one more bank, which is a river bank, right? So which bank you are telling, that will be understood by the other words. That is why only it will break down into words. Yesterday I was telling, when you give the prompt, it will break down into words and it will try to understand the context and it will remove the stop words. Yeah, it will do some modeling. Okay, then it will that this will happen very quickly because all the background processing happens in supercomputers. Right? So this is the basic background of how things actually work. Next is the transfer learning. So pre-trained on large data sets, especially for NLP tasks. Now let us see some of the models. Okay, a few people were waiting for this, right? So models like the Vector and BERT were actually developed by Google, right? And models like the Chat GPT-1, or sorry, let us not say Chat GPT, let us say GPT. Okay, GPT models like the GPT-1, 2, 3, 4, all are developed by the OpenAI. Then we have Glove, which is developed by Stanford University. Then we have Roberta. Roberta is actually developed by Facebook. Okay, and we have Elmo, which is developed by Allen NLP. Okay, so like that, people have a lot of companies have been working on different AI models, right? Which is actually giving good results for the for the development of artificial intelligence. So next is why these models are important or why these language models are important. Because they are the backbone of the modern NLP. And the models like BERT and GPT are the backbone of modern NLP. So they all use these language models. So yesterday I was telling understanding the grammar, understanding the tone, understanding the relationship between the words, allowing for building advanced tools like the chatbots, translators, summarizers, and search engines. Okay, so for everything we need. So even I was, focusing on the, thing called as grammar as well. Sorry, as grammar as well. So how the grammar plays a very important role, right? Subject predicate plays a very important role, especially using the voice assistants. So there were actually two different kinds. One is the static, one is the contextual, right? So word to vector and glove, these were actually used before the transformer technology was into the real world. When the contextual came, that entirely changed, like the BERT, GPT, and the Elmo models. Okay, so these, especially these models, were focusing on the contextual. So that is what that is what I was telling you about the the self attention mechanism also. That is, attention means the context based. All right. Next is one such example. You will understand that he sat by the bank to watch the boats. Okay. Now in this context, for example, if you put this into BERT, okay, it will understand that bank as a river bank, because you are saying here that the word which makes bank a river bank is the word boats. Only the word boats will in that particular context will make you to understand, that will make the model to understand. So not me, I know, we are human beings, we know, but the model will understand based on the word boat. So boats indicate that, oh, this is a river bank, not a financial institute. Okay, so now let us talk about the bidirectional encoder, bidirectional encoder representation from transformers. This is the heading for BERT. I told you, we will talk about the concept of BERT. Okay, so before that, let me just NLP is natural language processing. Here in the image you can see. In the image also it's mentioned. So yeah. Guys, please. Okay, I don't think any question for me. You're chatting in the please guys, please concentrate. Okay. Okay, just let's just go for a short break and come. Yeah, I think we are back. Yeah, so let's continue. So many questions again. Guys, please ask some fair questions, man. Uh, so BERT, you can see it on the screen, first of all. So I think that I need not answer that question. 28 questions. Oh my God. Yes, I mean, that is what only. Something same again they're asking. Many people, please just listen to what I'm telling. Then, if you still have some genuine doubt, please ask. Okay, so this will just delay our learning process. Okay, so so if I stop answering your questions again, you'll feel that sir is not answering. So I just don't want to do that. Um, all right. Um, so Kirtana, you can see it on the screen. What is BERT? Anyway, I'll explain it now. CNN is convolutional neural networks. I already told you. Okay, and there is no one. Everything what I told only again you are asking the same thing. That is not a question. See, something which I told in that if you have a particular doubt, okay, you have a particular thing specifically which is related to what I'm speaking and what I have told. Something which is beyond that is called as a doubt. What you're asking is not a doubt. A few people, guys, please listen to what I'm saying. Then you take a call on that. Okay. Then you ask whatever you have. Okay. I'll definitely clarify it. Okay. So let us talk about what is a BERT and how this, especially this technology, has evolved. From the hands of Google, right? Because I know by this time that transformer is what Google has actually developed, right? And this was done in the year 2017, correct? So if a technology is coming, based on one certain technology, obviously it will be after that, right? So that is why the BERT was actually launched in the year 2018. And it was, there's a correct word which I used here, right? So the word is nothing but revolutionary. So BERT is a revolutionary language representation model developed by Google AI and released in the 20 October 2018, right? So it transformed the field of NLP by introducing deep bidirectional pre-training, okay, allowing models to deeply understand the context of words in a sentence. That is why when you search something in the Google, it will always give you what is entirely related to that particular words what you have typed in the search. Your search results will be related to what you have typed, right? That is the creativity, or that is the secret behind that, right? So BERT is the secret behind that. So BERT is basically a transformer encoder architecture. I think by this time you understood that. And it is not like GPT, because GPT uses both encoder and decoder. Okay. Sorry, decoder part. GPT basically uses the decoder part, but BERT only uses the encoder part. So it is designed to read text in both the directions, left to right, right to left, simultaneously to build a richer understanding of the language. So because sometimes, you can see some people typing big sentences in Google, right? So if your question is very bigger, right, it is very big. So it takes time for the model to search from only one direction. So that is why they have developed it in a both direction. So immediately it will start reading the sentence from left to right and right to left, so that automatically it will read faster. And the results, it will take that split of millisecond. You remember when you search something, you just press it for search. It takes that millisecond, to appear, the results to appear. That millisecond time, that's where the BERT functions, okay, in the background. So these are some of the tasks which are actually done by BERT. One is the MLM, which is masked language modeling. Okay. So next is the, I told you that in Google, if you search, the cat sat on the. Okay. So if you, if you search like this, your suggestions will have, one more probability will have something called as mat. So you used to have that saying, the cat sat on the mat, right? So that is why it'll be able to predict that word. So BERT predicts that it is mat. Okay. The next, sentence prediction. So learns whether a sentence B logically follows a sentence A. Helps with the Q&A and natural inference. All right. Next, some of the use cases is basically the sentiment analysis. So sentiment analysis is nothing but understanding the sentiments of the users, right? So based on your sentiment, the content will be generated or modeled for you, right? Next is question answering and named name entity recognition, NER. And this NER, we are going to use it in natural language processing, text classification, and then search ranking, which is used in Google search. Okay. Next is advantages. So you can see the state-of-art performance, particularly in NLP. Find tuned models, right? You are seeing all these things. Limited is not designed for text generation. BERT is not for text generation, right? We already understood that. It's just a classification, which is an encoded model. So computationally expensive. Obviously, it is expensive because all the models which are built by transformers are expensive. So it only limited up to 512 tokens. Okay, the sentence length. Anyway, we'll not ask that much big sentence. So yeah. Next is applications of generative AI. Okay, so the generative AI part, what we were actually speaking about, it is not just content with the labs, right? We have it in entire industry, like the software industry, healthcare industry, drug industry, right? So everywhere we are using this generative AI. So the tools what we are using, like the Jasper, I think Jasper, many of you don't know. It is basically used to create vlogs and all those things, right? And Google Translate, many of you use it. So all the language translation is done by the BERT model. All right. Next is writing the emails, translating, summarizing, right? All these things, summarizing the documents, making the documents, everything is actually the applications of generative AI. And one more use case, some of the use cases are the DALI, Midjourney, and the Stable Fusion. Right? These are some of the, applications which are, there in the real life what we are seeing now. So the use cases, you can see the tools and the use cases. All right. So yeah, we're aware of many of these things. Next is the code generation. And for that, one of the tools is GitHub, right? So why GPT, for example, how many of you would have got doubt that how ChatGPT is giving you, programming codes, right? I don't know whether you got the doubt or not, because OpenAI is actually, I can say, is partnered with a company called GitHub. I think a lot of people know GitHub. So GitHub is actually a repository for all the projects on many projects, right? For example, like it might be from data science, Java, Python, C++. So for a lot of areas, it is actually it is like a database. It is like a repository. Now, this OpenAI, when they partnered with GitHub, they used all the resources of GitHub to train their models, to train their GPT models. Yes, to train all their GPT models. Now, whatever the codes are there, whatever the codes which have been developed inside, which are developed and which are being stored, you know, which are stored inside, the GitHub, all are accessed for training purposes by the OpenAI. So once these are trained, right, now it is ready to generate something. So it is generating new codes, new things. Yes, that is how it is actually generating stuff. Okay, so yeah. So next is music, and you can see jukebox and music gen. Personally, I have not used jukebox and music gen for tools for music and all. I have not used. Probably if you have used, maybe you can just tell it. Okay. So for games and videos, you have, you can use it for personalized assistance. I've just heard of it, but not much of I've used it, right? So you can just check with that. Next is the drug discovery. So this is the DeepMind. Okay. So DeepMind is basically the AlphaFold, which is actually using for this, drug discovery and science. So these are basically AI-driven drug discovery tools. Okay, so basically what this happens is it speeds up the drug decision process, finding treatment pathways for rare or complex designs, complex diseases. So modeling proteins for medical research is one of the things as per use cases. Now, since we have seen what is the language models, let us see about the large language models. Okay, when we talk about the large language models, so all the large language models are based upon the language models. So basically, they use the transformer architecture. Okay, so all of them use the transformer architecture. And if we have to talk about the large language models, one of the most famous language model is the ChatGPT. Even your Claude, your Google Gemini, everything is basically a large language model. Okay, so this basically understands the human request and generates whatever the human actually wants. This is the job of the large language models. So they are basically trained on huge amount of data sets like the books, articles, websites, right? So everything what is available in the web. I told that how OpenAI how OpenAI has actually partnered with how actually they have partnered with GitHub, right? In order to learn all the codes to teach, like to help their models build, learn. It's basically called learning only, right? So how the models will actually learn and build themselves. So and then they're able to generate new content, novel content, right? Like that, all the models, basically like the large language models and even the textbooks, articles, websites, everything, these are actually trained by the chat GPT or Google Gemini. These are because they are assistants, right? They are GPTs, right, which is using the transformer. They are generative models, right? And these use the transformer architecture, the core innovation allowing them to understand the context and relationships between them. So I think by this time you would have understood what's a transformer, all right? So can generate, summarize, translate, and even reason based on text input. So many things they can actually do. So I think many people also would have used Google Gemini. So Gemini is also kind of good. Yeah, I would also rate Gemini is good actually. It in a lot of areas it functions really well. So how do they work? They actually work on the mechanism of transformer. So built around self-attention mechanism that help the model decide which words matter most in the sentence. I told based on in a particular sentence, it will try to identify what is the important words, what is contributing to the context of understanding, what is important. So models learns patterns and relationships across billions of words. So in the sentence, the bank is on the river. The model uses context to know bank refers to a geography but not finance, because it is, you are saying river, no? So it will be a river bank but not a financial institution. So these are some of the popular LLMs which are available in the market, right? So something like the ChatGPT, Llama, right, and Gemini. right? And one, one person was asking me, I remember, I was telling, sir, why Elon Musk has launched Grok, uh, if he's already having, ChatGPT. So actually, OpenAI is not only Elon Musk's; it is, multiple people have found it. Okay, so this was Grok was especially developed by Elon Musk. Okay, not by him, means it's like he hired, people, AI engineers to do that. Next is the Perplexity AI. So this is also one of the AI models which is used. Even Google Gemini, it's good. Claude is good, right? So these are some of the LLM models which are available in the market. So yeah. So next is what how they work. This is the image. Yeah. So next is what can LLMs do? Okay. So how you can see them in action, right? So you can see them in action, especially when you are summarizing the text, right? Or you are generating a text, right? You are doing some translations. You are solving some real world problems, right? You are generating a code, right? Whenever you are doing all these things, you are seeing the LLMs in action. So I think all, at least one task in all these things, whatever I told, you would have at least done, right? So you have used the LLM models. So, I'm giving one small example. Explain Newton's third law to a 10-year-old. Okay. So if I say this, right, the output will be, on a particular, with sentence. I just put for an example. If you ask more examples, right, it will give you more detailed examples. Correct? No. So with a lot of explanation. Okay. So if you say 5-year-old, it will go below. If you say just put Newton's third law, so maybe at our level it will give. Right. So it is based upon, that is how you give a prompt. That is how you get a reply. Okay. Next, let us talk about a very, very important uh, concept called as prompting paradigms. Okay. So prompting paradigms are very important, especially for AI agents and the generative tasks. Because for AI agents also, you have to communicate with the AI agent, right? In order to get your work done. So in that process, it is very important that you follow a certain, rules and regulations. So that only are the three components, that is the zero shot, few shot, and chain of thought. Okay. Which are the three paradigms which are there in the prompts. Okay. So let us see those in action. First thing is the zero shot. Zero shot is nothing but a clear and a simple. That's why we are calling it as zero shot. So that means you're just asking something, it is just doing something. So it is very it is very clear and simple. No logic, no magic, nothing, just straightforward, like gunshot. All right, so that is basically zero shot prompting. All right, after that you have one more thing called as a few shot prompting. Then we'll come to chain of thought. So what is a few shot? Few shot is nothing but asking the model to generate some examples. So if you are asking to generate some examples, it has to perform a few tasks, right? For example, it has to understand the specific format, according to the situation. For example, you may ask to give examples on this particular thing. Okay, so it has to understand the context, it has to understand the scenario, what exactly you're asking, what is the situation, right? It has to analyze everything in and around. So all these things come into the picture. All these things come into the picture, especially when you are using a few shot prompting. Okay. Next thing is, you need to specify. Yeah, I've mentioned briefly, I'm explaining. You can just read whatever I've shared in the. So use when you need the model to follow a specific format or tone. You're performing tasks that require structure or transformation. right? So specific format. For example, the tip I've given a small tip where few shot prompting improves consistency and accuracy for a structured outputs. For example, like email formatting, translation, question generation. So all these things are come under few shot prompting. Next, the third one is the chain of thought prompting. So chain of thought prompting is nothing but something which the model has to think. Sir, it's a machine, know how it will think. It will think on logical reasoning. It will apply the reasoning, how to do a particular thing, right? So it can solve, it has to, think on the model which has been built, how it can process a certain aspect. So that it will think. Okay. So you're saying that for the model to do something which is complex, which it cannot just do like this, just simply it cannot do. So it has to follow some reasoning steps. So that is in where we are calling it as chain of thought prompting. All right, got it. Now the next thing we'll go to the prompt engineering. Okay, so let us talk about the concept of prompt engineering. Okay, now to understand prompt engineering, it is very important for you to focus on a certain things, which is the workflow. Okay, so the workflow in an AI prompt engineering is the information, for example, prompt. Okay, so the prompt to come to your, the reply to your prompt will come through different things, right? So the things, the model which is actually building upon, it has databases included, it has the workflows, it has the prompt libraries, it has the prompt receipt, right? So recite where it collects all the information, which kind of thing it has to give. Then it uses all the methodologies. Then it will come as an output in the AI as a generative AI output. So this is how a prompt engineering actually works. This is a very simple image. I kind of like it. So it's easy for you also to understand how prompts actually work in the real time. So next is the 12 important features under prompt engineering. These are the 12 important things which are there in the prompt engineering. So you can just read for yourself, right? So leads to more self-ask, meta prompt, chain of thought, react, symbolic reasoning, PAL, iterative prompting, sequential prompting, self-consistency, then art, automatic reasoning and tool use, then generated knowledge. So these are the 12 different things where the prompt engineering actually works upon. All right. So next is, this is the key concepts in prompt engineering. So prompt engineering basically starts with first prompting. The first step is basically prompting. So prompting is nothing but precisely formulating inputs given to AI language models. Okay, so that is called as prompting. So specifically, you are mentioning that what your AI tool has to generate. Okay, so that is basically called as a prompting. So next thing is context. Once you have prompted a certain thing, it has to understand the context, right? So that is in where relevant background provided to influence the response. So this contextual understanding only is done by transformer. Okay, this is the second step where the transformer comes into the action. Then NLP takes over, where the language models, it builds into tokens, then it applies fine tuning, and then it gives you the outputs. This is how the things work inside the prompt engineering. Next is, let us see some of the important aspects or the best practices, especially in the field of prompt engineering. Okay. LLMs like ChatGPT are powerful, but how well they perform depends on how you talk to them. That is what I was telling to you. So how you communicate with the GPT model, it is going to give your output. So you have to craft your prompts in a very beautiful way to extract. See, that is why I keep telling people using ChatGPT, everybody will do. Using ChatGPT to extract what exactly you want is an art. It's an art because it has a lot of things. You have to pull in what is required for you which will solve your purpose. So prompt engineering is about crafting your instructions in a way the model understands clearly and delivers what you want consistently and effectively. So, sorry, efficiently. So if the model has to deliver consistently and efficiently, that is in your hands. Don't say that ChatGPT is not giving me properly what I'm asking. That is what you have to, uh, clearly tell or communicate with the GPT model to get the best out of it. For example, the first and the key, first and primary important part is the use clear, unambiguous language. For example, don't give any vague prompts like write about something about marketing. What something about marketing? What is this rubbish? You should tell clearly what you want in marketing. So now see, write a 3-paragraph blog. This is just for example. Okay. So write a 3-paragraph blog post introducing digital marketing to college students. How is this prompt? How is this prompt to the write something about marketing? You only check. You just type this, whatever I told in your ChatGPT and check. The way it will give both the outputs, you see the difference. Same ChatGPT only, but how come output is different? Right? Does it know that I have for this person I will give like this? It doesn't know. Then how come the output is varying or changing? Right? So how how it is actually differing? Think logically how it is actually differing, because the way you have communicated, that is different. The way you have communicated, what you are extracting from it, it is different. Right? You have given a clear prompt. That is why my first rule is always use clear, unambiguous language. Never use vague prompts. So, I personally, when I use, okay, my prompts will be 2 lines, 3 lines, 4 lines also. That much I will, give a clear prompt. So I will mention every aspect what I need. Every aspect what I need, I will mention. Every aspect. So if you have 10 aspects, in your text generation, you have to give all the 10 aspects in a proper sentence, proper English. Don't give in, all butler English or, without grammar. That is why I told, because they are at the end of the day, they are LLM models. They use natural language processing. So if you give something without grammar, if you don't use proper spellings, proper subject predicate, proper all the grammar parts of speech, don't use everything properly in a good frame of sentence, it will not understand. So this much is required. Yes, it is required, man. It is because it is an NLP model. It's a natural language processing model. It's a large language model. Obviously you need you need it to actually uh, give you need to extract the best out of it, right? So next is specify role, task, context, and output format. Even the output format you can specify, right? For example, act as a resume. See the prompt what I've given. You'll understand. Act as a resume expert. Your task is to review a resume and give clarity on, feedback on clarity, tone, and structure. Output will be bullet points with improved suggestions. So it will again ask, you want me to specify, make these changes. Then you can say, yes, make these changes. I don't want like this. Please make it like that. Like that, you have to communicate. That is only prompt engineering. Understood? No, that is how you're training the model that is how you are tuning your transformer to understand you. That is in your hands, no? So now use delimiters also. For example, you can summarize one article, right? Even in summarizing, you can mention. Okay. So please keep points which are very important for this particular aspect. Okay. Which link to this particular this particular, I would say this particular context. Okay, like this you can make it to understand, make it to feel that how you are feeling. Yes, you can do all those things with ChatGPT. I think many of you would have not have tried this much. Just vaguely, randomly we put. Never do that. Never do that. You will not get the proper outcome. Then you just take whatever is coming, just this much only it is giving. No, please communicate with it. Like how you talk to your friend, right? To make him understand, you will explain it in a clear way. Tell that only to ChatGPT. You tell as a friend, think as a friend, talk as a friend, explain it. It will give you the best results. Okay, so try it. Okay. Next is refine iteratively, right? So if the output isn't right, rephrase or add constraints. That is what I try. That okay, don't give me this particular context. I don't want that. Give me an example or something outcome on this particular context. I don't want this. Okay, so like that you try to communicate. So obviously, what will happen is, what happens if you're doing like this is, especially it will try to understand in a very easier way, and it will actually give you a better results. All right. So next is next. Let us go to the example prompt. Okay. So act as a career counsel. For example, act as a role. That role you give, your task is to input and you get the desired output. Act as a career counselor. Your task is to write a professional summary for a data analyst resume. Now, in job profiles also you can see they are using all the AI generated for a particular role. Always, this was the problem with job profiles, right? So they push out something, they ask for 100 things, which in reality you only do 1 or 2 things in the company. Trust me. So don't be scared with the job profile, because and now this has become even more worse with this AI generated tool, because they are not specifying to the role, just they're randomly giving. And because I have seen a lot of job profiles where people just ask for this is one person, how he will know all these things? It is very difficult. So they're just vaguely generating in an AI tool and just putting it, and they're sending it out. So never do a vague, or never give a vague prompt to the GPT models. Okay, so they are uh, they are not something which will understand if you vaguely give something. So you can try this prompts later. Okay, I just wanted to show you, but I think many of you are already aware of. Okay, but usually I show this, but you can try. Okay, the first prompt you can see like this. You go in an order. First, you give in your ChatGPT, explain photosynthesis. Okay, you try. This is like a homework for you guys. Okay, so just type explain photosynthesis. You will get a textbook type of explanation. Okay, because you have just given explain photosynthesis. No, now next you change the prompt to explain photosynthesis to a 10-year-old. First one, first prompt you generate explain photosynthesis. Then you see the output. Now put explain photosynthesis to a 10-year-old. Now you see the difference between both the outputs. The second output, this to a 10-year-old, it will be more simple, because you are asking for a 10-year-old. So more, in a simpler language with a very simple examples you will find. Next, to the third prompt, you give explain photosynthesis to a 10-year-old using bullet points and a metaphor. So in this, you will see a metaphor like, plants are like solar panels, like this you can give. Okay, so if you are knowing any metaphor, you can mention those metaphors also. Okay, or you can say with which kind of examples, which which kind of metaphors also you can give. So like that you can simplify the prompts. You'll be, if you try the same thing in a different way, you'll be understanding how the model is reacting. Okay, so this is a small exercise. Okay, okay, so you try these things. Okay, you will understand in a better way what I'm trying to tell. Now, this is one part. Now, my fourth prompt is explain photosynthesis to a 10-year-old using bullet points and a metaphor and 3 examples from everyday life. Okay, so the examples will be everyday life. That means things which we are seeing. For example, like park, house plants, algae. So like this kind of examples it will give. So the 10, now explain photosynthesis from there. See the prompt, how it has changed. So it was just a simple prompt. It has changed, okay, bit bigger, okay, as a sentence. Now it has become even more bigger, almost it went to 2 lines. So the same prompt we have used in a different way, which will yield different results. So anyway, I'll share this PPT. No, you will try this. Anyway, you'll be remembering this. Not a problem. You can try any prompt. So like some just make the changes. Try to understand the differences. That is important. Just don't simply just put the prompt and see whether ChatGPT is working or not. don't do that. Okay, it will work. But your job is to identify the differences in the to identify the differences in it. All right. Now, let us go to the diffusion models. So before going into diffusion, if you have any questions, you can just ask. Okay, good. The questions have reduced. It was like so many. I don't understand the word GitHub. Sorry. GitHub is actually a repository. You can just search for GitHub. You'll get it. How does BERT differ from other language models? Why should we only use Java? It is not ChatGPT, it is ChatGPT. Google is different, ChatGPT is different, man. Google search, when you search something, it uses if you search something in Google, it uses normal BERT technology for classification. Okay, but now now things have changed a bit. When you search something, especially, you are getting one AI based results. You have seen that. That is generated by Gemini. So here what is happening is two things are working. Gemini is a GPT model. Yes. So you're getting some information in Gemini as well, which is working as an AI tool. So that is what it is showing in, it is searching in Gemini, it is showing the results. Apart from that, BERT is also working. So Gemini, so LLM model as well as BERT, both are working there actually. But one, see, okay. But if you see carefully, only the difference is the kind of model they have constructed. Okay. So which kind of model they are actually using? Okay, for which kind of task is what the difference is. Yeah. So let us talk about the diffusion models. Okay. Just give me a minute. Uh, That has already been shared. Okay, so let us continue. Question again. Okay, so let me just discuss this. Okay, let us talk about the diffusion models. Okay, so there is one particular technology, which is called as a diffusion model. Okay, I remember on day two, one person was also asking, I don't exactly remember the name, but I remember a person asking about the diffusion models. Yes. So, I just wanted to tell when the time has come, okay? Because, it will be a bit clumsy, if I just talk about everything at one place. All right. These particularly are used to reduce the noise in the images, okay? Because you are generating a text to image conversion models. For example, like the DALI, Midjourney, Stable Fusion, right? All these models are used or which are actually used to, to convert text to image, isn't it so? So when you're using these from text to image, right, it is very important that it actually doesn't capture any noise while constructing. While the model doesn't, capture any noise into the image. Okay, so that is made sure by the diffusion models. Okay, so think of it as starting with static noise and cleaning it up slowly with a beautiful beautiful image emerges. All right. So, the core idea is from chaos to clarity. So that is why I've mentioned this reverse the noise heading, and the core idea is from chaos to clarity. That means diffusion model starts with a random pixels and learns how to reverse the noise step by step to generate the realistic images. All right. So they're trained to simulate how noise corrupts images and then undo the process like playing a movie backward from static to clarity. Okay, why they matter? Produce stunning high resolution images, great control over detail and creativity, have revolutionized AI image generation. So AI image generations, I did not tell. Many of you would have already used it, right? You are aware of it, so you have a great clarity already. So popular tools for diffusion models is the DALI. The first tool which comes to my mind is always DALI. Okay, because I've used it more. And you have Midjourney as well as the Stable Fusion. So these tools run text prompts to hyper realistic or stylized images by guiding the noise, reverse the process until your words. So the simple analogy is think of it like cleaning up a fuzzy static TV screen. Each step removes a bit of the noise until a clear image magically appears. Okay, so this is what the diffusion models actually do. Okay, so tomorrow we'll stop here. Okay, so we'll just apply these prompts and we'll apply and build. We generate images to prompts. Sorry, from prompts to images. Okay, so this building of generating images we'll see tomorrow. I have a few prompts as well, which we will use it for generation. So let us see that for some time. Okay, and then let us go to the AI agents tomorrow. Okay, so that should be the main agenda. So yeah, exactly here we can stop. Actually, that will create, it exactly the flow will be there tomorrow. Okay. Uh, Yes. So any questions if you have, you can please ask. Okay. Yeah, till here exactly I just wanted to teach today. Okay. So we'll continue from that building of using a few prompts, how we can give and extract images. I'll just show you some demo. Maybe some 15-20 minutes, just trying to understand what happens in an image and all. Then we'll go with the AI agents. Okay, what are agents? How it is linked to what we have discussed, because all the linking process we have discovered. Now we will link it with the AI agents. In understanding what is agentic AI agents, why we are using all those things, we can, yeah. You can please mark your attendance also. Ma'am has shared the link. You can just mark the attendance. If you have any questions, the material will be available. Okay, the material will be available. Okay, I just inform ma'am. So how AI models knows how to create an image or video just using the prompt or a query given by the user? Yeah, I will tell you that in detail. Don't worry. Tomorrow we'll discuss that. Good. But there is a certain element which is linked to it. I actually have discussed. But just think on how it will create. Okay. By just think. I'm giving the clue by transformer. Okay, so it will understand the context and it will start creating an image. Okay, so already discussed it, but I think probably you would not have just not able to connect the dots. I guess you can just think on it. Because before we have a session tomorrow, you can just think on it, and we will build on that. All right. So any other questions? AI inserts to output, or it can set a goal. It can do both. It is actually AI agents. All the AI agents are goal-based AI tools. Okay. How it will take the prompts, how it will. I'll tell you about Notion AI. Actually, this one I just want to even put it in the I'll just put it in the PPT also, because a lot of people were asking this. Okay. Okay, so that is one thing which we will discuss. Okay. So anything else? I'll talk about that, man. Apart from that, anything? Yep. Sure, we'll do it. There's a lot to discover, man. Just be patient. We'll do that. Sure. Uh, Ma'am, you're there in the meeting? I think that's it with the questions.
Yeah, yes, sir, I'm there.
You're there. Okay, great. Fine, ma'am. Then we'll end the session then.
Yeah, sure, sir. Thank you.
Yeah.
In by tomorrow at 7 p.m. Thank you so much.
Yeah.
Students, I'm just sharing attendance link once again on the chat. Please mark your attendance. It's already shared. I hope you all marked it. For the day, we'll meet again by tomorrow at 7 p.m. Thank you. Good night, everyone.